All right, let's dive in. Today, we are talking about a really powerful new way to understand the world around us. From the impossibly tiny to the unimaginably huge. It's this idea from our source material called Measuracy. And I'm telling you, it might just change how you see, well, everything.
So have you ever had that feeling where big numbers just start to blur together? You hear a million, a billion, a trillion, and they just become meaningless words. The truth is, our brains just aren't wired to get a feel for the true scale of reality. We really do get lost in a sea of zeros. I mean, just think about how absurd these scales are. On one side, you've got Planck time. That's the shortest possible unit of time that means anything, a number with 44 zeros after the decimal point. And on the other, the age of our entire universe, which is a 1 followed by more than 17 zeros. They're just numbers on a page, right? They don't feel real.
So, seriously, how are we supposed to wrap our heads around that? Our minds simply are not equipped for it. We can say the words, sure, but we can't actually feel the difference. And this huge gap in our intuition, it actually has a name. The author of our source material calls this Immeasuracy. Think of it like a form of physical illiteracy. This built-in inability to really understand and work with physical quantities. It's why we all struggle with this stuff. But what if there was a way to learn the language of scale? What if we could become measurate?
The good news is we don't have to stay lost in all these numbers. There's actually a key, a way to unlock this language of scale.
And the solution is this new skill called Measuracy. It's the ability to truly get a feel for these massive quantities. And the secret weapon? The key to it all is a super simple mental tool that just makes these crazy, incomprehensible numbers suddenly click in our brains. Okay, it's called magnitude notation, and it is beautifully simple. For big numbers that are powers of 10, you literally just count the zeros. So a million is a 1 with 6 zeros. Its magnitude is 6. That's it. For small numbers, you just count the position of the first real digit after the decimal point. So a millionth, 0.000001, that first 1 is in the 6th position, so we write its magnitude as -6. See? So easy. So what does this do for us? Well, it means we can take a big, clunky number like 1 million, with all its intimidating zeros, and we can represent its scale with just one single intuitive digit, 6. We've basically tamed it. It's no longer this scary monster of a number, it's just a 6. Now, this is not just some neat little party trick. Let's see how this simple tool helps us build a real, actual intuition for the world around us. From something as simple as our own heartbeat to the mind-boggling scale of entire galaxies. Okay, let's start with time. We'll set our baseline as a single heartbeat, which is about 1 second. So its magnitude is 0. Makes sense. Now what about a human century? That comes in at a magnitude of 9.5. In the entire age of the universe, it's just 17.6. All of a sudden, that jump from a century to the age of the whole universe feels manageable. It's not this infinite sea of zeros anymore. It's just a leap from 9.5 to 17.6. We can feel that. And guess what? This works for distance, too. Let's make an arm's length our baseline, about a meter. So that's a magnitude of 0. Okay, so the diameter of the Earth, that's just a magnitude of 7. The diameter of the entire visible universe, an almost graspable 26.9. This notation kind of makes the cosmos feel a little less intimidating, doesn't it? But this isn't just for doing cool comparisons about the universe. Let's apply this new skill to one of the biggest challenges we're facing right now, energy. And this is where it gets really powerful. So here we've got a comparison. It's the energy that's packed into jet fuel versus what's in a modern lithium-ion battery. Now, we could stare at the raw numbers all day, but the magnitudes, they tell a much clearer story. Jet fuel has an energy density magnitude of 7.6 joules per kilogram. A really top-of-the-line battery, it's sitting at 6.2. And right here, this is the aha moment. That difference of 1.4 in magnitude might not sound like a lot, but remember, this is a logarithmic scale, so it's huge. It means jet fuel packs 25 times more energy for the exact same weight. And just like that, you intuitively understand a fundamental limit of modern engineering. You now know. You can feel why we don't have battery-powered airliners. Measuracy also makes power crystal clear. A physically fit human can put out about 2.5 watts of power for a while. A car engine? that's around 5.0 watts. And a single engine on a Dreamliner jet, a staggering 7.9 watts. That jump in magnitude shows you in a really visceral way the immense power difference required for modern flight.
So look, here's the bottom line. You now have a new tool for thinking. It's like a new lens that lets you see all these hidden relationships of scale that are all around us, from your daily commute to the great challenges of our time. You now have the tool. So the only question left is, what are you going to use it to understand next?